Why don't we just have nuclear power in satellites and basically everything we have floating around space? I mean,
well, the thing is that the SNAP satellite went up back in like 61 or 62, I think, and it was nuclear powered. But ever since, it's been kind of looked down upon, especially after some of the I guess disasters that happened, with Chernobyl and Thermal Island and things like that. Nuclear power was frowned upon after that. But now that this problem is rising, like the eyes of NASA are kind of being turned towards this alternative.
What other forms of power could they use though? Because I mean, like you said, solar's kind of out. Batteries wouldn't last that. I mean, can you just like a row of 9-volt batteries? Would that work? Power moon base maybe, or satellite?
I was like, you need batteries right now? What? Sorry, I'm paying attention. I swear.
So, what other alternatives are there, or are we pretty much out of alternatives? Is this really the best solution?
Yeah, I'm a very strong advocate of this because along with a nuclear reactor, you're obviously going to get a lot of power output, and that is a very, very, very useful thing to have, especially when you're powering a lot of equipment and things of that nature. And then the same goes with space propulsion. You need this nuclear reactor to power what I'm doing. Plasma propulsion. Electric propulsion is very, very, very energy intensive. So you need to have a lot of power that solar might not necessarily be able to provide.
So it's small, it's efficient, right? So a lot of these satellites have those giant solar wings that kind of hang off of it. We wouldn't really need to have that anymore, I assume, for satellites at least. It's small and it's efficient. I assume it works well in space because isn't nuclear power just a giant steam engine essentially, or am I thinking of something totally?
No, you're more or less right. I mean, it's gonna work a little different, obviously in space, but more or less, a reactor, it basically harnesses the heat given off by a nuclear reaction, and then uses that to heat up water, which in turn steams, and then turns turbines, and they generate power out of that. We're using a couple different things that I'm not as involved in. That's I forgot which center is doing that, but they're helping us out a lot. They're going to have a lot of influence on that. What we do actually, at least what I've been involved with, is the method that they're going to use to cool the reactor. One of the things that presents a problem in space is that just moving parts and things of that nature obviously aren't going to be that accessible. So one of the things that we're implementing is a liquid metal pump, actually, that works off of electrical forces and magnetic fields that actually pumps this liquid metal through a reactor without having any moving parts. So it lasts a pretty long time.
Sounds like something out of a Terminator movie. Isn't it? It's not going to become self-aware, is it? This pump is not going to be the
Skynet.
Skynet, exactly.
No, it's actually it's really, 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 really simple. It sounds like it's some crazy advanced thing, but it's just a couple of magnets with a pipe running through it and an electrode running through it. I mean, it's a great design. A lot of thought went into the way it's built, but overall, it's very simple.
What's interesting is a lot of space tech ends up being very, very simple because you can't have a lot of complex things in space. Because how do you get to them to fix them?
What is that, Occam's
Exactly.
razor?
No, I don't think that applies here.
To a certain extent. The simplest answer is usually the truth.
Yeah, but
It's usually the best one.
I'll give that one to you. All right.
Yes.
So we've got this nuclear surface power, and you also work in propulsion, plasma propulsion. Is that correct?
That's correct.
Tell me a little bit about that.
Okay, plasma propulsion, basically what it does is it takes an electrical current and passes it through a gas, and then it ionizes that gas, and then it uses that ionization, that electrical field, in sync with magnetic applied fields through either permanent magnets or inductive coils that produce electromagnets, and it produces force, and then that force, it's smaller than if you were to take your hand, stick it out in front of your face, and blow on it. It's smaller than that. It's millinewtons of force, but at the same time, it's a lot more efficient than conventional rockets systems that we have right now with chemical propulsion.
So you don't really
Wow.
need a whole lot of power once you're in space. Is that my understanding? Is you don't have to have a whole lot of thrust. You just kind of keep applying it, and you just keep going faster and faster and faster and faster. Is that the idea?
Exactly. I mean, you see the big, like the SRBs on the main on the shuttle,
Yep.
and then you have the main engines on the shuttle itself, and you see that those thrusters only last for a matter of minutes. A plasma thruster or an electric propulsion system will actually last on the order of somewhere around 20,000 hours or more.
Wow.
Well, is that
Yeah.
enough? Do you constantly use it for all 20,000 hours straight, just to keep it going like a satellite going fast, or a lander going fast, or how would you actually break up that 20,000 hours? And how many years is 20,000 hours? Is it like less than one? Is it?
It's like 5 days.
I have
I'm
no
just kidding.
idea. Someone do that math for me in the chat room. How long is
Yeah.
20,000 hours in days or years?
It's a long time. It's a heck of a lot longer than a couple of minutes.
Ustreamer 573 says it's 43 days. So 43 days worth of constant thrust.
But it depends on the type of thrust you're using. When you get into plasma propulsion, there's different types. There's pulsating plasma thrusters, and then there's constant thrust systems. So it just depends on which type you're using.
Right, and right now we use generally pulsating thrust, correct? I mean, like when you think of the space shuttle, that's it's not even 8 minutes, but we'll call it, just for sake of being easy, 8 minutes of constant thrust.
Yeah.
Yeah, right, because you got the SRBs that launch, and then you got the main engines that keep going. And then when they're moving around in space, they've got just bursts of thrust. Would that be fair? But what you're talking about is you could do 43 days of just straight thrust to move you forward. How does this... So, okay, we've got the nuclear surface power, and we've got the propulsion. I assume that's driven by the nuclear power as well, the propulsion, or does it not need to be?
It would be very beneficial to be doing that because of the very, very high energy required by plasma thrust systems. If you guys are really, really interested, all you guys in the chat room and my viewers, look up the rocket equation. Actually, I think you can find it on Wiki. It's a very, very interesting thing that really, really shows you the difference between chemical and plasma propulsion, and how, with a chemical system, you have to take, sometimes you take like double your payload in just fuel. Whereas, with an electrical propulsion system, when you take maybe a couple extra 100 pounds, and it lasts that much longer. So it's something really cool to look into.
By the way, it looks like our calculations were wrong. We said 43 days. They just ran the calculator. We have a calculator in our chat room. I'm not kidding. We actually have a calculator in the chat room.
Yeah, I know.
And they're saying that it's 833.3 repeating days worth of power. So that's several years worth of constant power is 20,000 hours. That seems a lot better than 43 days. 43 days didn't seem right.
Well, I mean, that's cool and all.
Yeah, I didn't think it was. But.
No. Yeah, 800. So that's years of constant thrust that we can apply. So, all right, we've got the power, the engine to power it. We've got the power source itself. How do we apply that to what NASA's trying to accomplish, going back to the moon and then on to Mars? Where does it help us there?
Well, so you look at pictures of the Ares 1 and 5. The Ares 1, I think, is the cargo vessel, right?
I think
The
so.
Orion is the crew module.
Right.
So then the Ares
Yeah.
Isn't it?
I don't
All
remember.
right, somebody in the room must know.
Yeah, someone knows somewhere,
Ares 5 is
the cargo.
cargo.
Ares 5 says Total Recall.
Okay. Well, regardless, whichever one is the cargo, you have the two SRBs down on the side, and you have the thrusters down on the bottom of the main vehicle. But one of the things that is going to come up is when we go to Mars, or something like that. If you were to launch a vehicle that was taking a lot of cargo and not manned, and you had plenty of time to do it, and you put enough forethought into it, you could just throw it up there